Previously on Chemistry Z, our heroes were transported to the ancient battlegrounds of atoms to explore their atomic size. Whilst there, they discovered the link between the periodic table and electronic configurations. But now, our heroes are being called on a quest to discover the origins of the periodic table itself. Will they be able to make it out safely? Find out in today's exciting episode of Chemistry Z. Here are the retrieval questions for this lesson. You know what to do. Gravity is a non-contact force. It is the tar in cigarette smoke that is carcinogenic. Remember, a carcinogen is something that can cause cancer. And proteins are used for growth and repair. Let's first look at the first 12 pure elements that were discovered.
Go and ask your grandfather.
First, it was copper and lead. To put these two dates in perspective, because we're in the 21st century, copper was discovered 12,000 years ago. Around that time, the Sahara Desert was not even a desert. Scientists refer to this period of the Sahara Desert's history as the Green Sahara because it was literally covered in plants. That's how long ago that was. Then we had gold and silver, iron and carbon, sulfur and mercury, zinc and arsenic, and then antimony and bismuth. Then in 1669, a bankrupt German merchant named Henning Brand, in a last-ditch effort to try and get rich, tried to create something called the Philosopher's Stone.
What? It's real?
Good guess, but actually no.
Before we had chemistry, we had alchemy. Alchemists tried to turn regular metals into gold. This is what Brand was trying to do. My guy actually got urine and heated it up where there was no air around, and then something that must have seemed magical occurred. He must have actually thought he created this because his lab lit up. It started glowing in a light that temporarily blinded him. That day, Henning Brand didn't discover the Philosopher's Stone, oh no. He discovered something better. He discovered phosphorus. Phosphorus the name literally translates to light bringer. This is the first of the modern elements that was discovered. Then man like Antoine Lavoisier in 1789 described an element as a substance that cannot be broken down by a chemical reaction. He wrote down 33 of the known elements in a table like this. Look very carefully at this. Here is the modern periodic table for contrast. Spend some time thinking about what the similarities and differences between the two tables are. Two similarities is that the tables both group their elements. So do you have different groups for your elements? And both tables have elements in common, so they both have oxygen and hydrogen, etc. But two differences is that Lavoisier's table contained compounds and energy. So we can see that we've got caloric, which was the old word for heat, which is energy, and then we had something like lime, which is calcium oxide. Also, the periodic table is arranged by atomic mass. The modern periodic table is arranged by atomic mass. As you can see, in this part of the specification, you need to understand that elements were first arranged in terms of atomic weight and not atomic mass like the modern periodic table. If you're doing some last minute revision, use the progress bar to skip to the next section because I'm about to go absolutely nerdy with this. You don't need to know this for GCSE. If you've got one around, grab a calculator for this next activity. In the 19th century, chemists had worked out something called the specific gravity of different gases.
See? When I'm telling you that what they want is to bring us here and punish us, you did not believe. Now you see?
It ain't that deep. It's just the density of a gas compared to the density of air. Then along came this fella, William Prout. He looked at the numbers and noticed that they were all multiples of the value for hydrogen. This was known as Prout's hypothesis. Here's a challenge activity for you to do. Use Prout's hypothesis to calculate the relative atomic weight of the different substances above. The relative atomic weight is just the weight of the element compared to hydrogen. The relative atomic weight is the specific gravity of the substance divided by the specific gravity of hydrogen. So if we divide each of these by the specific gravity of hydrogen, which is 0.0694, we get the relative atomic weight. And let's look at these numbers. Some of them looks familiar, don't they? We've got 16 for oxygen. If you look at your periodic table, we've got 1 for hydrogen, obviously, because we're dividing it by itself. And we've got 12 for carbon. Now that we understand what atomic weights are, along came this brother called John Newland, who arranged all the known elements in terms of their atomic weight. But then he noticed something interesting. He noticed that a periodic pattern in reactivity occurred. Every other 8th element reacted in the same way. For example, hydrogen and fluorine are highly reactive gases. Lithium and sodium are reactive metals that turn water alkaline, etc. He likened this to the same way how the white keys on a piano repeat every 8th note. And so, his periodic table was called Newlands octaves. The periodic table was now starting to look closer to what we know today. But please do not forget this important difference. Newland's periodic table was arranged by atomic weight, the number that we calculated in the previous example. However, our modern periodic table is arranged in terms of atomic number. I'll geek out and explain how atomic masses worked out in a later video, but now let's finish off what we need to know for the syllabus. Scientists at them times didn't take Newland's table too seriously. Because Newland strictly ordered his elements by atomic weight, some problems occurred. For example, he put iron, the most metal of all metal elements, in the same group as oxygen, which is a gas, and sulfur, which is a yellow brittle non-metal. It made no sense to them scientists. They didn't rate him at all. And then my guy stepped into the scene to pattern the whole periodic table once and for all.
Let's end this. I'm about to end this man's whole career. I'm done.
The word genius is overused in our modern world, but this brother, Dmitri Mendeleev, he was a genius. He became a teacher in 1867 and started writing a textbook on chemistry. This textbook right here. One night, he claimed to have had a dream where he saw the completed periodic table arranged perfectly. This is what he had to say about that dream. I saw in a dream a table where all elements fell into place as required. Awakening, I immediately wrote it down on a piece of paper. Only in one place did a correction later seemed necessary. He published this table in 1869. This table alone would have made Mendeleev an OG, but he did so much more. He predicted elements that hadn't even been discovered yet. He was so confident in his logic for the periodic table that he left gaps in his periodic table. For example, he predicted 4 undiscovered elements: Eka boron, Eka aluminium, Eka manganese, and Eka silicon. Spend some time looking at the periodic table and predict where he would have placed these undiscovered elements. Here is where he was looking to place those undiscovered elements. Now, I weren't gassing when I said my guy was an OG. I need you guys to just deep how amazing his mind was. Just based on where his undiscovered elements would have been on his periodic table, man like Mendeleev made all of these predictions. Here are just the predictions made about one of these undiscovered elements, Eka aluminium. And then 4 years later, gallium was discovered. This was when all doubt was lifted and Mendeleev told his haters, shut up.
Man, Shassie's better than me. Tell my man shut up. Shut up.
And here is the finished product. Around 90% of the elements are metals, and these are located on the left and the middle part of the periodic table. The non-metals are located at the top right and they go down in a diagonal section like this.
I have the power!
I'll go into more detail on the groups that you need to learn in the next few videos, but for now I'll just mention that metals form positively charged particles called cations and non-metals form negatively charged particles called anion. Hydrogen is one of the few exceptions that we have here. This table is actually amazing. Just by looking at it, you can understand the electronic structure of an atom of that element. If you want to know how you can work out the electronic structure from the table, click this video on the side to go to a video where I did on that. Also remember that we now order elements in terms of their atomic number, which is the number of protons in the atom. Atomic weight was a poor system to order elements because some elements have isotope that skew the numbers a little bit. And there we go! Lesson done!
Fatality.
As I said, I'll go through the specific groups in the upcoming video. Use the timestamps to skip to where you need to go. Check out my flashcards in the description along with the revision timetable, and I'll catch you guys in a bit.